But if you want to stay here and you're not here, then you need to talk to your counselor about it. Okie dokie smokies. Also, if you are an extended time person, you need to fill out that form for your semester exam, which is Friday, December 16th. Now, I want it done now. So if you are going to be extended time for the exam, you need to fill that form out. This is very, very confusing for people like me. I need advance notice to be prepared. You know when the exam is, there's no reason not to do it.
If my birthday is the day of the finals, can I use the bonus point?
Okay. 5. Hopefully you're not taking the exam in May. Right?
For real, bro.
For real. All right, here we go. Number 5. Number 5. Okay, we got the lighthouse. They drew the picture. Express the distance as a function of the angle x. Well, that's easy. What function are we going to use? What trig function are we going to use? Cosine? So we're going to say cosine x equals 350 over d. Would you agree with that? Now, be careful. It says express d as a function of x. So that means get d by itself. Okay? So d cosine equals 350, and d equals 350 divided by cosine x. Is everybody okay with that? Then it says, if x is 1.55 radians, what is d? Well, that's not a very hard problem. 350 divided by cosine 1.55. Did you get 16,831? Right? And that would be feet. That was easy. All right, number 6. Solve graphically with the calculator. Secant equals cotangent. And we're between negative pi and pi. So, what do you think I'm going to do with these numbers as I solve graphically on my calculator? What's that? X min. And this is X max. All right, so that takes care of that. So let's go ahead, let's go to window, negative pi, and pi. Now, my y's, I don't know, unless I don't even know when I'm asked graph, but my y's are negative 10 to 10. I'm just going to leave it there for a minute and see what happens. I'm going to go to y equals, and I'm going to type in, oh, how do I type in a secant? How do I tell my calculator to graph secant? 1 divided by cosine x, okay, and then 1 divided by tangent x, and hit graph. I wish I had a new calculator where they were in colors. As it was graphing, did you see what you expected to see for a secant? We talked about this last time. What do secants look like? A bunch of parabolas, asymptotes and parabolas. And then what does a cotangent look like? That squiggly thing going down. Did you see that? Yeah, it's exactly what you expected. Now, do they cross anywhere? Now remember, we're only looking in this one interval. It looks to me like they cross in 2 places. Okay, so how do we, you know how to do that, so go ahead, let's find where they cross. And it looks like they cross at 0.67. Would you agree with that? I'm looking for X values now. And
Odyssey standard.
Yeah.
what's the other
How do you
one?
get the
I got 2.48.
How do you do the intersect?
Second trace.
How do I go into that intersection?
I'm not sure.
Those look like- Anybody else get those?
Yeah.
Lucy?
I don't know how to get from one parabola to the other one.
Just keep going, it'll go by itself.
Oh, okay.
Just keep the arrow moving, it'll go up and then come down.
Do we not need every intersection?
Huh?
Do we not need every intersection?
We do, I thought that was all there were. Are there
No,
more?
only two.
There's only two.
My calculator's got 6.
Remember, the asymptotes are different, so we're not talking about where we cross asymptotes or anything like that. It's where the two curves actually cross, and I think those are the only places.
What's your X?
My window?
Yeah.
Pi and negative pi.
Yeah, I don't know, I think that's all we've got.
But not windows on
Okay, now, while we just have that graph and we're looking at it, actually we're gonna be doing some more graphing here in a minute. All that stuff we were doing before lunch, there are many, many answers. Every time somebody says sine x equals something, there are many answers to that question. I hope that makes sense to you, because if you graph a sine curve, okay, and let's say you want it to be 1/3. Well, here's where 1/3 is. Do you see why there are infinitely many answers, guys? Because it just keeps going forever and ever. So in those exercises we did before lunch, they basically were giving you a chunk of the graph to look at. Where do we cross in that chunk? But we were doing it without graphing. Okay, but now we're going to graph. Now we're going to graph, oh, by the way, that completes 4.5, so that'll be due on Monday. And now we're going to graph a combination of trigonometry, and in this case, a quadratic. What happens when we add those together? We could do it manually, but it would take a long time, and we have these calculators, we might as well use them. So we're between -2 pi and +2 pi. So that's gonna be our window, or our x's anyway. -2 pi and +2 pi. And we're gonna put in our we're gonna put in one equation, add them together. We're not looking where they cross, we're actually adding them together. So sine x plus x squared. Get graph, and let's see what happens.
Window range here.
Window range. Make sure your mins first. I don't know how that would happen. Now, it's graphing on a calculator, and we're checking to see if any are periodic. So we're not it's not finding the zeros or anything like that. What does periodic mean? Periodic means it repeats, not necessarily like this, that's deceptive. Periodic means you can graph it by taking one chunk and pasting it end to end, and that's how you get the whole curve. So like for a sine curve, it's a hill and a valley, and then a hill and a valley. For a tangent, it's a squiggly, and then the squiggly, and then the squiggly. Does this thing appear to be that way? In other words, is there a chunk of it that just keeps repeating itself? No. I mean, it's a cool shape, kind of a parabola-ish thing, but not periodic. All right, let's try the next one. X squared sine x. yep.
Periodic. Periodic. Periodic.
All right, did you get some kind of fun shape?
I think it could be periodical.
Okay, I like the way she's thinking. She says, maybe I don't have enough here to tell. So just for fun, let's change our window. Why don't we do, what do you want to do? Negative 8 pi to 8 pi. I don't think so either, because when does C start? I just wrote that down somewhere. C starts at 120. Okay? So this does not appear to be periodic. Periodic again means that you can draw one piece of it, like let's say that. And then that same piece will generate the entire picture. And that isn't what I'm seeing on this one. All right, I'm gonna set my window back to how it was supposed to be, negative 2 pi to 2 pi. But I love that, Marin. I love the way you were thinking about that. Okay, sine x squared. Be careful when you type this in. When you type sine, that parentheses automatically comes in, right? To square that, you're gonna have to manually put in another set. So you're gonna have to put in parentheses, sine, x, close both parentheses, and squaring. All right, what happened here? Definitely looks periodic, doesn't it? All right, and the last one, sine x squared, and the squared is inside the parentheses. Sine x squared. Now, this is not periodic, would you agree? But there is something going on. What kind of special thing is going on?
The symmetry.
It has symmetry about the y-axis, which, oh, by the way, for the exam review means it is even. It's an even function. That's an exam question. I did the review last time. That's an exam question. So we are, that's an even function. It has symmetry about the y-axis, but it is not periodic. Good, good, good. Okay. Let's leave our window the way it is. And would you graph number 2, 0.5x plus sine x. Now, this equation is a combination of sine, and you know what sine looks like, and 0.5x. What's 0.5x? 0.5x is a line, right? So does it kind of make sense to you that you've got a sine curve following a line? All right. What the problem, and you can kind of tell, but what the problem is telling you is there are 2 parallel lines, and your curve is oscillating between them. Now, you don't physically see the lines, but does that kind of make sense to you when you look at your picture? So here's what I want you to think about. What is the biggest value that sine can have? 1. Think about it. When you graph a sine curve, what's the highest point? 1. Unless you make some adjustments like putting numbers and stuff in. But a regular sine curve has a maximum of 1. Guys, go back to your circle. There's your unit circle. What's the biggest y value on that circle? 1. That is your sign maximum. What's your sign minimum? -1. So this equation, y equals 0.5x plus sign, is going to oscillate between 0.5x plus 1 and 0.5x minus 1. Just for fun. Leave that one on your graph, but go back and put in these two equations so that you're graphing all three at the same time. 0.5x plus 1, 0.5x minus 1. Is it exactly what we thought? Boy, we are amazing human beings. All right, one more thing. 4.6. 4.6 is going to be due on Monday also. Do I see you tomorrow?
Yeah.
Right? Okay. Good. Tomorrow we'll do our review, 4.4 to 4.6. And then the next time I see you,
Great.
we'll take our quiz, which is just a quiz. All right, but let's do number 3. Number 3 is the last one. Find the period of the following. Which ones are sinusoids? Now, sinusoids have the general shape of a sine or cosine. Remember, don't sines and cosines have exactly the same shape? It's just a matter of where you start them, right? So, we can, obviously you could graph this on your calculator, but we can do it manually. What is the period of this part right here? Just this guy. 2 pi. So the period of this one is 2 pi. What about this one? What's the period of this one? What's the period here? 2 pi. Sine and cosines are 2 pi. Unless we change them by putting numbers in. When the period of each piece is the same as it is here, it's sinusoidal. So if you graphed this on your calculator, it would have a sinusoidal shape. And the period of that sinusoid would be 2 pi. Now I think you understand it's very easy to make them not match, right? But if they match, that's how you tell it's sinusoidal. All right? The period of the whole shebang, in this case, is 2 pi. We'll figure out how to find the period of the others in a minute. All right, so let's look at the second one. What is the period of the first piece? 2 pi over 5. What is the period of the second piece? 2 pi over 3. This is not sinusoidal. However, it is periodic. There's a difference. Sinusoidal means it's periodic like this. Periodic means it can have any shape at all that just repeats itself. Right? So we have a bunch of triangles repeating themselves. To find the period of the sun, think about what's happening in this picture. At 2 pi, we're starting at 0. There's no phase shift or anything. I'm talking about this right here. Starting at 0. At 2 pi over 5, we repeat ourselves. We start over again. That's what period means. It starts over again at 4 pi over 5. And again at 6 pi over 5, 8 pi over 5, 10 pi over 5, and so on. And you just go as far as you want to go, okay? This is when each of these pieces starts over again. Would you agree with that? Now, what about that one? Well, it starts at 0, and then repeats at 2 pi over 3, and 4 pi over 3, 6 pi over 3, 8 pi over 3, and so on. The first number, the first place that they both start over again is the period of the sum. So, I want you to look at this number right here. What is that reduced to? What is this reduced to? So the period of the sum is 2 pi. That is the first overlap they have. So if you graph this on your calculator, we don't have time to do it, but you can take it home and do it. If you graph this on your calculator, you're gonna see some weird thing, but then it's gonna start over again at 2 pi, and it's gonna start over again at 4 pi, and so on. Whatever the weird shape is, it will not be sinusoidal. All right. C. What time did I say this ended?
Wait, how did you said it's the first place where they
Overlap, where they have a match, the first match. Okay, I think we end at 1:15. So you can work on C and D on your own. I'm gonna consider this finished. And tomorrow we will review using that review sheet I gave you.